What's Gooch, everybody? It's AJ here again, and today I want to start the first of hopefully a couple videos, or maybe a lot of videos, about cryptography. Now, cryptography is another field of computer science that is concerned with transferring information safely and effectively using different types of algorithms or encryptions. Now, at its most basic level, encryption is to enable two people to communicate over an insecure channel in such a way that an opponent cannot understand what is being said. This could be, for instance, a telephone line or a computer network. So think of it as I'm Bob, and there's a girl named Alice, and I'm trying to send Alice some information. Basically, I want to send her information. It could be over the internet, or again, like I said, a telephone line. But along this path, many people, let's just say Bill Gates, call him BG, or Steve Jobs, want to know what I'm saying, so they have a chance to intercept this transfer or see what's being transferred when I transfer it over an insecure channel. Now, let's just say I'm trying to make a new OS that will be better than Windows and Apple. So Bill Gates and Steve Jobs are trying to figure out what is on that, even though Steve Jobs is dead, God bless his soul. But so what Bob and Alice need to do is to ensure that their ID doesn't get stolen, is they need to use some method of cryptography to encrypt their information. Now, basically, the idea of a crypto system, as it's called, is a 5-step process. So let me go down here. Like I said, the crypto system is a 5-step process, and you're going to have P, which is a finite set of possible plain texts. So it's a way plain texts. So it's a way that the user can communicate, for instance, the letters of the alphabet. And then there is E, which is a set of cipher texts, which is a way to encrypt the information, as I will show you a basic cipher text at the end of this video. But E is a set of cipher text. So it's a way to somehow shift your information so that it's unreadable if someone were able to find it. And then there's K. And what K is a key space. And a key space is a set of possible keys. And a set of possible keys is what allows you to encrypt the cipher text. So if you know the key, you can easily evaluate a cipher or decrypt a cipher code. And then there's E and D. And so E is the process of figuring out or deciphering the function such that now I can decipher the text in part E. And E, the process in the set of E must be unique. The keys must not be there must not be multiple keys for one answer. There must be only one key that gets you the right decryption for your message. So this is the process of decrypting the message. And this is the actual decryption, the actual message that was originally sent. Okay, so there you go. That's a brief introduction. As you can see, it spells PEKD, P-E-K-E-D, which is perfectly okay. That's kind of the way I like to think about it. As you can see, the two E functions are the way you are allowed to encrypt and decrypt the information. So, sorry, these two ways can be thought of as the encryptor and the decryptor. Because obviously one encrypts the message and one solves the message. So you can call this E2 and E1. I guess I should decipher that a little bit more. And yeah, so there you go. That's a basic introduction. That's the way of how you want to be able to use cryptography in the real world. Is you want to be able to send a message over an insecure channel, so you're able to so someone is able to get it and be able to decipher without anyone else knowing what is going on or what it is. Now, a simple cipher that I will show at the end of this video is called the shift cipher. The shift cipher. And the shift cipher, let's do that. The shift cipher is pretty easy. And it says for K, which is between 0 and 25, I'm going to define EK1 to be X plus K mod 26. And then I'm going to do EK2, which is the decryptor, equals X plus K, X minus K, sorry. This should be a different variable too. It should be Y minus K. Sorry, my bad. Mod 26. And so this first step here is the encryptor, and then the second K2 is the decryptor. Let me show you guys a quick example. If you don't know what modulus is, simply for positive numbers, it is basically a function to find the remainder on whatever you do it on. For instance, and in programming, it's usually shown as a percentage sign in most languages, so that's a quick thing to know, as this cryptography has the most to do with programming. So for instance, if I did 10 mod 2, well, 10 divided by 2, what's the remainder of that? It's basically saying, okay, 10 divided by 2, what's the remainder? So what's the remainder of that? It's 0. And let's say I did 10 mod 22. Well, 10 divided by 22 is 0, but it has a remainder of 12. So that's your quick mod overview. It's basically the remainder. You can treat it like a division and just do a remainder. So let's say I'm going to do a quick cipher shift example for you guys, and here we go. So let's say I have a word that is meat. I have meat. I just want to tell the word meat. And it may be meeting or it may be something else. I could make it more and say meat, but we'll just do this basic word for now. And what I want to say, and so basically, how am I going to decipher this? Well, in the cipher shift I showed you for K 0 through 25, as you can see, 1 through 25, 0 through 25 allows for 26 digits. And if you think of A as being 0 and Z being 25, you are allowed to represent every single alphabet character as a number. So that's what we're going to do. So I'm going to represent. So if I was going to do this with A being 0 going up to 25, meat would be 12. It would be 12. Then it would be E would be 4, and then T would be 19. You can double check if you want, but I've got the list right here. So there you go. I've got 12, 4, 4, and 9. So now I'm going to apply the first encryption cipher key on this. What I'm going to do here is I'm going to add. Oh, sorry, I forgot to talk about something. So now I have these in this mode. So now the next thing I have to do is I have to follow the procedure, X plus K mod 26. Now, something I forgot to mention is what is K? what could K possibly be? Now K is the encryption key I talked about. Now how do I know what K is? Well, it is also designed for this solution. The key must be known by both the sender and receiver, which must have been discussed maybe before on a secure network where no one could know what the key is, or somehow be a private thing that no one could possibly have access to, because if someone has the key, they can break the code. So K is whatever the key is. For now, we're going to say that, and K can be anything, as I showed you, from 0 to 25. So K is the key and is going to allow us to be able to be the only ones to encrypt this system. But as you'll see, that's not really the case because the computer can hard crack the system. So let's say I'm going to say K, the key equals 11. And so right now I'm going to, again, follow my formula X for the encryption. I'm going to encrypt it. And so I'm going to do X plus K mod 26. So right now we're going to do that. So 12 plus 11, I believe, is 23, Michael Jordan's number. And then I'm going to mod it by 26, which is simply 23. And now I'm going to do 4 plus 11, which is simply 15. And so mod 26 is nothing, well, it's 15 again. And same thing for the other 4. And now I'm going to do 19, which is going to be 30. And then mod 26 will be 4. So now I've done that. Now I've encrypted it. So now I will send this message, 23, 15, 15, and 4, over my unsecure network, my television, my LAN or my WAN, my WAN or telephone line, and simply I'll do that, and then Alice, the other side, the receiver, receive it, and he'll see these 4 numbers, and he'll know the key because we've discussed that on a secure channel, and he'll simply do the second decryption equation where he will take EK2, do Y minus K, mod 26. So what does he do? He takes 23, he minuses it by 11, which goes back to 12. Ooh. And mod of that is simply 12 again. 15 he'll minus by 11, which is simply 4, and mod by that is again 4, 15, 4, 4. And then he will do 4 minus 11, which is negative 7. And that will simply, the answer to negative 7 mod 19, while maybe a little difficult, kind of think of it as how close, if I were to do, it's basically think of what I did, since it's on the negative side, I'd think of it as negative 7 divided by negative 26, and what's the remainder of that? Well, since they both cancel out, again, it would be 0, but then I'd have a remainder of a positive 19, so I get back to that 19. And as we showed, if you looked at the character board, M is the 13th letter in the alphabet, which corresponds to the 12 because 0 counts, so you would add 1. And then 4, if you do A, E is the 5th letter, so simply these both are 4. And then 19, again, like I showed you in the beginning, is T. So I get my original 12, 4, 4, and 19. Now the Cypher shift is one of the simplest shifts and really is not used encryption at all because simply the fact is, while it would take a little while for a human to break this, it wouldn't be that difficult, is that a computer could break this by simply looking at your numbers and trying each key. Like I showed you in the beginning, there's only 26 keys. There's only 0, 1, 2, 3, 4, 5, 6, 7, blah, 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 24, 25. So simply a computer could look at each separate key and see if any of those keys printed out anything that was worthwhile knowing, and then you could decide what information you wanted to take from that text. So that is simply one of the simplest shifts, and we'll be getting into more shifts later, guys. I hope you enjoyed this tutorial, and I hope you guys have a great day. Check out my website, subscribe, Facebook, and check out my website, please, again, and have a great day.